Hello and welcome to Cotton Innovations Limited. At Cotton Innovations Limited, as you've seen with our series of videos, we love to share the tools that we use with people to help them deploy and improve their processes. And if you need to reach out to us, the details are at the end of the video. We would love to help you with this. In today's subject, we're going to be looking at understanding risk. And what do we mean by that in terms of knowing fit to spec? This is part of the series that looks at FMEA. One of the things you need to know from an FMEA perspective, failure mode and effect analysis, is how well does my data fit to the specifications. Now, why do I need to know that? If I'm managing risk, I'm looking at a special cause or a common cause. Common cause, it happens all the time. Special cause, we're looking at a one-off event. So when we're talking about fit to specifications, there's two terms we need to understand, and those two terms come in two categories. There's what's called a CP or a CPK, and we need to understand what those terms mean. Those terms can also come in two other categories, a PP and a PPK. So to understand what those mean, we first of all need to understand the terminology. C stands for capability and P stands for process. And because it was invented by a German gentleman by the name of Schuhart, they would, compared to English, they changed their verb structure. So the verbs appear at the end of the sentence. So they would say, is the process, they would not say, is the process capable, as we would talk about it in the UK, but they would say, it's a capable process. There is a capability in my process. So where does the K come from? The K is a term which is called constant. Now, what do we mean by constant? It's a value that always exists. Now, if you spell constant in German, you spell it with a K, not with a C. So this means it's a constant. What do we use as a constant? It's the mean of the data, and we'll see that in a moment. PP, PPK are two other terms. So people have often talked about this being production process or long-term data. The key difference between a CP and a PP and a CPK and a PPK is that these two here use an estimate, standard deviation, and these two terms here use the actual standard deviation. Now, why is that important? It's important because if I have patterns and problems in my data, my CP will miscalculate. But it's also useful because I can compare my CP and my PP, and if those numbers are similar or they're different, then I know that I've got problems, that my data is not normal, I've got issues in my data that I need to resolve. If I can also use PP if I have small sample sizes. So reach out to us if you're doing CP, CPK, you want to understand a little more about them, how the maths works, how to be more useful in interpreting that information, and we would love to help. Details at the end of the video. But how do I calculate CP, CPK? How do I refer to it? Well, CP. Let's call our CP on this side, and for just clarity of the page, we'll put our CPKs on this side. And we're not going to use maths to help us dissolve these figures or resolve these figures. We're going to use pictures. So if my process looks like that nice big fat distribution, I would declare my CP is 1. And why is it 1? Because my spread fits once in the spec. Fantastic, that's so simple. If I was to look at a CP of 2, my process would look like this. My process could fit twice in the spec. Oh, but Brad, you've drawn this and it's not in the center. Well, we'll come to that in a moment. Equally, a process that looked like this would have a CP of 2. Fantastic. Absolutely brilliant, so simple to look at. And then if I'm then looking at a process where my process looked like this, my CP would still be 2. Why? Because just like this one, it could fit twice. Like this one, it could fit twice. Like this one, it still could fit twice. But here I have a problem, and here I have a problem because I'm not on target. We'll come to that. That's why we use the K to help us locate where it's supposed to be. And then finally I have a process that sits here and it looks like this, and my CP is still 2. Why is it 2? Because the spread could still fit twice. Doesn't fit at all. So we need to talk about our process capability from a spread perspective. We also need to talk about our process from a capability perspective. Now this is where we're going to talk about where does it fit. So here we're going to do 2 calculations. We do a calculation of the mean of this half of the data and a calculation of the mean on this half of the data. We calculate both, but we quote the lowest of those 2 values. So in this case, we would see that this half, that fits once, and this half, that fits once. So our CPK here would be 1. So our CP is 1, and our CPK is 1. Now we're going to use this one. Here's the mean of our data. This side, my data fits once. This side, my data fits once, twice, 3 times. However, I'm going to quote the lowest of these 2 values. And I also need to tell you in which direction it is going. So I would quote the CPK lower because we're now talking about this limit here, the lower specification limit. It is 1. Why is it 1? Because this half fits once, this half fits 3 times, and I'm telling you that my data is towards the lower limit. The bulk of my data is towards the lower limit. Well, let's come back to this one here, CP of 2. What would my CPK be? Well, I would calculate this side once, twice, and this side once, twice. So for this process, it doesn't matter whether I quote CP or CPK, but my CPK lower and my upper both equal 2. So again, as we said in this first one here, when the CP and the CPK are the same number, my data is centered. So now I can tell you I have good spread, poor location, good spread, great location. Well, what about this one here? This is a really interesting one, because now my mean and my CPK, my mean and my spread are on the same value. And when I do the math, I find that this half doesn't fit at all to the lower spec limit, which gives me a value of 0. But this side, 1, 2, 3, 4. So my CPK upper and lower, this one will be 4 and this one will be 0, because against the lower spec limit it doesn't fit at all, which automatically tells me that 50% of my process is out of spec. Well, what about this one? This is a really interesting one. Again, I'm going to take my mean at this point here and I'm going to calculate the mean of my data against this limit, and I'm going to calculate the mean of my data for this side against that limit. And what I'm going to get here for the CPK lower and the CPK upper is this side fits with a score of -1. Okay? And on this side, it's going to fit 1, 2, 3, 4, 5 times. So in all of these, I would ignore the uppercase and the uppercase here, and my CPK would be quoted as the lowest value. Now we've drawn the drift always going to the lower spec limit. If the drift was happening to the upper spec limit, we'd be quoting that the upper spec limit is our lowest CPK value, and that's the one we're going to quote against. Reach out to us at Cotton Innovations if you'd like to know more on how to use the CPK. It's a really, really powerful tool to help you understand where my process sits. How does this fit with FMEA? Well, we're going to talk about occurrence. How often does something occur? CPK will tell you how often you will see failures or outliers or issues in your process. So reach out to us. We'd love to help you, and this has all been about the fit of my data to my process. Really, really powerful tool, needed for FMEA, needed for lots of other things. Reach out to us, we'd love to help. Bye-bye now.